Welcome and overview. Welcome to the channel. Please consider subscribing. I produce videos daily covering wide variety of cloud topics with focus on networking. I will be comparing load balancer, CDN, and WAF solutions across AWS, Azure, and Google Cloud Platform. In today's cloud-native world, these three components form the critical foundation of any scalable web application. Let me walk you through why each matters. Load balancers distribute traffic across multiple servers, ensuring no single server gets overwhelmed. CDNs cache your content globally, bringing it closer to your users. And WAFs protect your applications from malicious attacks. Over the next slides, we'll dive deep into how each cloud provider implements these services, their unique features, and most importantly, how traffic flows through their architectures. AWS Load Balancer Solutions. AWS offers three distinct load balancer types, each designed for specific use cases. Let me explain when you'd use each one. The Application Load Balancer, ALB, operates at Layer 7, perfect for HTTP/HTTPS traffic. I've used this extensively for microservices architectures where you need path-based or host-based routing. For example, routing API * to your backend services and images * to a different set of servers. The Network Load Balancer, NLB, works at Layer 4, handling millions of requests per second with ultra-low latency. This is your go-to for TCP traffic, gaming applications, or IoT devices. Finally, the classic load balancer is the legacy option. I'd only recommend it if you have existing EC2 classic deployments. For new projects, always choose ALB or NLB. The diagram shows how traffic flows from users through Route 53, AWS's DNS service, to your chosen load balancer, then to your EC2 instances across multiple availability zones. Azure Load Balancer Solutions. Azure takes a different approach with its load balancing offerings. Let me break down their two main options and when to use each. The Azure Load Balancer is their Layer 4 solution. Think of it as Azure's equivalent to AWS's NLB. It's blazing fast and handles both inbound and outbound scenarios. I've seen it handle massive gaming workloads without breaking a sweat. Application Gateway is where Azure really shines. It's their Layer 7 load balancer with built-in WAF capabilities. This integration is brilliant because you get load balancing and security in one service. You can enable SSL termination, URL-based routing, and even multi-site hosting. The traffic flow diagram illustrates how Azure Traffic Manager, their DNS-based traffic routing, directs users to the appropriate region, then through either load balancer or application gateway to your VMs or app services. Pro tip: if you need global load balancing, combine Traffic Manager with regional load balancers for a truly resilient architecture. GCP Load Balancer Solutions. Google Cloud's approach to load balancing is perhaps the most elegant, with a unified global load balancing service that's incredibly powerful. Their HTTPS load balancer is truly global. You get a single Anycast IP that works worldwide. I've deployed applications that serve users from Tokyo to New York on the same IP address, with Google automatically routing traffic to the nearest healthy backend. The TCP/UDP load balancer handles non-HTTP traffic at scale. What's unique is that Google offers both regional and global options for these protocols. Internal load balancers are perfect for your private workloads. Think database clusters or internal microservices that shouldn't be exposed to the internet. Look at the traffic flow, it's beautifully simple. Traffic enters Google's global network at the edge location nearest to the user, then travels on Google's private fiber to your backends. This means consistent, fast performance regardless of where your users are located. The real magic is in their health checking and automatic failover. It just works, often switching traffic away from unhealthy instances before you even notice there's a problem. CDN Solutions Comparison. Now let's dive into CDN offerings. This is where things get really interesting. Each provider has taken a unique approach to content delivery. CloudFront, AWS's CDN, has the most edge locations, over 400 globally. What I love about CloudFront is its deep integration with other AWS services. You can origin from S3, ALB, or even API gateway with just a few clicks. Azure CDN is actually multiple CDNs in one. They partner with Akamai and Verizon while also offering their own CDN. This gives you choice, but can be confusing. Their standard Microsoft CDN is solid for most use cases and integrates beautifully with Azure storage. Google's Cloud CDN takes a different approach. It uses the same global network as their load balancers. Fewer POPs than AWS, but they're all premium locations with massive capacity. The integration with cloud storage and compute engine is seamless. The diagram shows how each CDN handles a typical request, from initial DNS resolution through edge location selection to origin fetch, on cache miss, or direct response, on cache hit. Here's a pro tip. Don't just look at pop count. Consider where your users are. I've seen cases where Cloud CDN outperformed CloudFront for Asian traffic despite fewer locations. WAF Solutions Deep Dive. Web application firewalls are your first line of defense against application layer attacks. Let me share what makes each provider's solution unique. AWS WAF is incredibly flexible but requires more setup. You build rules from scratch or use managed rule groups. I particularly like their rate-based rules for DDoS protection and their integration with CloudFront. The new WAF v2 is much easier to use than the original. Azure WAF comes built into Application Gateway and Front Door, which is brilliant for simplicity. You get OWASP core rule set protection out of the box. Their custom rules engine is powerful, and the integration with Azure Sentinel for security monitoring is top-notch. CloudArmor is Google's answer to WAF, and it's deeply integrated with their load balancers. What sets it apart is the use of Google's threat intelligence. They see a huge portion of internet traffic and use that data to protect you. Their adaptive protection learns from your traffic patterns. The traffic flow diagram shows how each WAF inspects traffic. Notice how Azure's approach of embedding WAF in the load balancer reduces latency, while AWS and GCP's separate services offer more flexibility. Real-world tip. Start with managed rules, then add custom rules based on your application's specific needs. I've seen too many teams try to build everything from scratch and miss obvious attacks. Integrated architecture patterns. Here's where it all comes together. Let me show you how these services work in concert to create a robust, secure, and performant architecture. In the AWS pattern, Route 53 provides DNS, which points to CloudFront. CloudFront has WAF rules attached directly. For dynamic content, CloudFront forwards to ALB, which distributes across EC2 instances. Static content is served directly from S3. This separation gives you fine-grained control. Azure's pattern is more integrated. Traffic Manager for DNS. Front Door acts as both CDN and WAF. Then Application Gateway, with WAF enabled, for regional load balancing. It's fewer services to manage, which many teams appreciate. GCP's architecture showcases their global-first approach. Cloud DNS points to Cloud CDN, which is backed by Global Load Balancer. CloudArmor protects at the load balancer level. Everything runs on Google's private network for consistency. Each approach has merits. AWS gives you the most control and options. Azure provides the most integrated solution. GCP offers the best global performance out of the box. I've implemented all three patterns in production. AWS works great when you need specific features from each service. Azure shines for enterprises wanting integrated security. GCP excels for truly global application. Feature comparison matrix. Let's break down the key features side by side. This comparison table is based on real-world implementation experience with all three platforms. For load balancing, All three offer solid options, but they differ in approach. AWS separates concerns clearly, different load balancers for different use cases. Azure integrates more features into each load balancer. GCP provides the most elegant global solution. Looking at CDN capabilities, CloudFront has the edge in number of locations and features like Lambda at Edge for compute at the edge. Azure CDN's multi-vendor approach gives you options but adds complexity. Cloud CDN's strength is its simplicity and performance. For WAF features, AWS WAF is the most customizable, with incredible flexibility in rule creation. Azure WAF's OWASP integration is excellent for teams wanting strong defaults. CloudArmor's adaptive protection and Google's threat intelligence are unique advantages. Price-wise, they're all competitive, but the pricing models differ significantly. AWS charges for rules and requests. Azure bundles more into the load balancer cost. GCP's pricing is often the most straightforward. My advice? Match the platform to your team's expertise and your application's needs. There's no universally best choice. Real-world implementation example. Let me walk you through a real e-commerce platform deployment I architected that handles Black Friday level traffic. This example showcases best practices across all three services. The architecture starts with multi-CDN for maximum availability. Yes, you can use multiple CDNs. DNS-based routing sends 80% traffic to the primary CDN and 20% to secondary. This gives you failover and performance testing capabilities. For load balancing, we use application layer, L7, for the web tier with path-based routing. The API * paths go to containerized microservices, while static paths go to optimized web servers. Network layer, L4. Load balancing handles the database read replicas for consistent, fast connections. WAF rules are layered. Geographic filtering first, blocking countries you don't serve. Then rate limiting, 100 requests per minute per IP, followed by OWASP core rules, and finally custom rules for the specific application. The traffic flow shows how a user request traverses all layers. Notice how we handle both cache hits and misses, and how the WAF inspection happens at the edge for cached content. This architecture handled 10 million requests per hour during peak, with 99.99% availability. The key was extensive load testing and gradual rollout of WAF rules to avoid false positives. AWS Complete Traffic Flow. Let me walk you through exactly how traffic flows through AWS's architecture from a user clicking a link to getting a response. This is crucial to understand for troubleshooting and optimization. First, the user's browser performs a DNS lookup. Route 53 returns the CloudFront distribution's domain. Notice how Route 53 can do geolocation routing here, sending EU users to EU distributions. The request hits the nearest CloudFront edge location. Here's where the first magic happens. CloudFront checks its cache. On a cache hit, typically 80 to 90% for static content, the response is immediate. No origin fetch needed. If it's a cache miss or dynamic content, CloudFront forwards the request to the origin. But first, AWS WAF inspects the request. This happens at the edge, blocking malicious traffic before it reaches your infrastructure. For dynamic content, the request goes to your application load balancer. The ALB performs health checks continuously, so it only routes to healthy targets. It can route based on paths, headers, or host names. Finally, the request reaches your EC2 instance or container. The response travels back through the same path, getting cached at CloudFront if appropriate. Pro tip: enable AWS X-Ray to see this entire flow with timing data. You'll quickly spot bottlenecks. Azure Complete Traffic Flow. Azure's traffic flow showcases their integrated approach. Let me trace a request through their stack to highlight the key differences from AWS. Starting with DNS, Azure Traffic Manager is more than just DNS. It's an active traffic routing system. It continuously monitors endpoint health and can do performance-based routing, sending users to the fastest responding region. Azure Front Door is where Azure really differentiates. It's a combined CDN, load balancer, and WAF at the edge. This means security inspection happens at Microsoft's edge network, not at your regional resources. For cached content, Front Door responds immediately from over 130 edge locations. For dynamic requests, Front Door uses Microsoft's private backbone network. This is huge for performance because your traffic never touches the public internet between Front Door and your origin. At the regional level, Application Gateway provides another layer of load balancing with integrated WAF. Yes, you can have WAF at both Front Door and App Gateway. Defense in depth. The request finally reaches your VM scale set or app service. Notice how app service abstracts away the infrastructure. You don't manage individual VMs. What I love about Azure's approach: the tight integration means fewer moving parts and often better performance for global applications. GCP Complete Traffic Flow. Google Cloud's traffic flow is elegantly simple yet incredibly powerful. Let me show you why GCP's approach is unique in the cloud provider landscape. It starts with Cloud DNS, but here's the kicker. You get a single, global anycast IP address for your load balancer. This IP works everywhere in the world. No need for multiple regional IPs or complex DNS routing. When a user makes a request, it enters Google's network at the closest edge location. Google has fewer edge locations than AWS, but each one is massively capable and connected to Google's private global network. Cloud CDN is tightly integrated with the global load balancer. If content is cached, it's served immediately. If not, the request travels on Google's private network to your backend, not the public internet. This is why GCP often has more consistent global performance. Cloud Armor, GCP's WAF, is integrated directly into the load balancer. Security policies are evaluated in Google's infrastructure before traffic reaches your resources. The global load balancer automatically routes to the nearest healthy backend. If a region fails, traffic instantly redirects to the next closest region. No DNS TTL waiting. Your compute engine instances or GKE pods receive the traffic, process it, and send responses back through the same optimized path. The beauty of GCP: it's genuinely global by default. You think globally from day one, not region by region. DNS Solutions Deep Dive. DNS is the foundation of your global traffic management strategy. Let me break down how each provider approaches DNS and global traffic routing. The differences are more significant than you might think. Route 53 is AWS's DNS service, and it's incredibly feature-rich. Beyond basic DNS, it offers health checking, failover, geolocation routing, and even geoproximity routing with traffic biasing. I love the alias records for AWS resources. They automatically update when your load balancer IP changes. Azure Traffic Manager isn't just DNS, it's an active traffic management system. It continuously probes your endpoints and can route based on performance, priority, or geography. The performance routing is brilliant. It sends users to the endpoint with the lowest latency, not just the geographically closest one. Cloud DNS is Google's offering, and while it seems simpler, it's rock solid. The integration with GCP's Anycast IPs means you often don't need complex routing. One IP works globally. When you do need routing, Traffic Director provides advanced capabilities. The diagram shows how each handles a multi-region failover scenario. Notice how Route 53 requires you to configure health checks and routing policies. Traffic Manager actively monitors and routes, while Cloud DNS relies on the global load balancer for most routing intelligence. Pro tip: consider using multiple DNS providers for critical applications. I've seen even these robust services have issues. DNS is too critical for a single point of failure. CDN Traffic Flow Comparison. Let's dive deep into how each CDN handles traffic differently. These architectural differences have real performance and cost implications for your applications. CloudFront's approach is highly customizable. You can configure different origins for different path patterns, set up origin request, response handlers with Lambda at edge, and have fine-grained cache control. The Origin Shield feature adds an extra caching layer between edge locations and your origin, fantastic for reducing origin load. Azure CDN's multi-provider approach is unique. The standard Microsoft tier integrates beautifully with Azure services. The Akamai and Verizon tiers give you access to those providers' global networks. This flexibility means you can choose based on your specific geographic needs. Cloud CDN's tight integration with Global Load Balancer is its superpower. Cache invalidation happens globally in seconds, and you get consistent behavior across all locations because it's all Google-controlled infrastructure. Look at the traffic flow differences. CloudFront's regional edge caches reduce origin hits for less popular content. Azure CDN's provider networks each have their own optimizations. Cloud CDN's integration means your cached and dynamic content follow the same network path. Real-world performance varies by region. CloudFront generally wins in the Americas. Azure CDN with Akamai tier excels in enterprise scenarios, and Cloud CDN often provides the most consistent global performance. Always test with your actual user distribution. Decision framework and best practices. After implementing these solutions dozens of times, here's my framework for choosing the right platform and avoiding common pitfalls. Choose AWS when you need maximum flexibility and have a team comfortable with complexity. Their services are incredibly powerful but require more assembly, perfect for large teams with dedicated DevOps, SRE resources. Azure shines for enterprises already in the Microsoft ecosystem. The integrated security features and compliance certifications make it ideal for regulated industries. If you're using .NET or have Active Directory, Azure is a natural fit. GCP is my go-to for globally distributed applications or anything that needs consistent global performance. Their networking is unmatched, and the simplicity of their services means faster deployment. Common pitfalls to avoid. Not testing WAF rules before production. I've seen legitimate traffic blocked. Ignoring costs until the bill arrives, especially egress charges. Over-engineering with too many services, and underestimating the complexity of cache invalidation. Start simple, measure everything, and evolve based on real usage. The best architecture is one your team can operate confidently at 3 a.m. during an incident. Questions to consider. Where are your users? What's your team's expertise? What's your budget for both services and operations? Answer these, and the right choice becomes clear. Thank you for your attendance. Please subscribe if you haven't done so yet.